Last video of lesson 25. Now this is actually going to be a very short one, at least in terms of the math involved. It's very, very basic. Please, 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 if I ask you to identify the conic, do not do anything more than this formula. It is very easy to use this formula to identify the conic. So, you have the conic identification theorem. Now, it says the graph of this, and notice this is the generic graph of any kind of conic, be it rotated or not. Ax squared plus bxy plus cy squared. It has the b in it, so we have that situation. Now, I think the coolest part about this is it says if the graph is a conic, and these are conics, then the graph can be identified by its discriminant. Wait, its discriminant? Isn't that b squared minus 4ac? These things don't have, wait. Parabolas are quadratics. Quadratics have discriminants. There's really a discriminant for all these, as long as we keep to this particular concept for this particular graph. Again, this works for us because of what we're given. Okay, because of what we're given. Now, in terms of the discriminants for this, we're very particular for what we're looking for, and again, there's a reason why it works out the way it does. An ellipse or a circle, we're going to have b squared minus 4ac is less than 0. That means that this piece here, squared, is going to be smaller than this piece times this piece. This piece times this piece. If I have b squared minus 4ac is equal to 0, this b squared minus the 4 times the a times the c is equal to 0. I have a parabola. Well, that just makes sense because the rotations will cancel itself out in terms of the parabola, and we shouldn't be left with anything. Lastly, the hyperbola is b squared minus 4ac has to be greater than 0. Has to be greater than 0. So if that's the case, let's just go ahead and identify all of these conics. Example, identify the conic sections using the conic identification theorem. I'm going to do it right on this paper because it's just that easy. What is b squared minus 4 times a times c? Well, b is negative 4. I'm going to square that. Minus 4 times my a value is 2 times my c value is 2. That's going to give me 16 minus 16. That's 0. This thing right here, I know to be a parabola. That's it. I'm done with that problem. Okay, again, in comparison to the problems back here, right here, these problems are a joke. Let's go ahead and look at the next one. My b value, in this case, is the negative 2. Okay, my b value is the negative 2. My a and c are non-existent. So let me square that. Negative 2 squared minus 4 times 0 times 0. This gives me a positive 4. That means we have something greater than 0, and this has to be a hyperbola. Okay? If we use the rotation theorem on this, we will actually get all the information we're supposed to, and we will recognize that as a hyperbola. This one right here. Let's go through this one. I'm going to have b squared minus 4ac again. My b value is a 5. I'm going to square that. Minus the 4 times my a value is a 3 times the c value, which is a 4. This is going to give me 25 minus this is 12 times 4. I don't even care that that's a 48. I just care that it's going to be something that's less than 0. If it's less than 0, this thing will then be a what? A circle or ellipse. Okay. Lastly, we'll look at this one down here. And we have my b value is 1. Be very careful with that. I do have a b value. It's 1. My c value is a negative 3, and I do not have an a value this time around. So I have b squared minus 4ac. My a value being 0. My c value being negative 3. So all in all I really have is this equal to 1. That means that I have something greater than 1, and therefore this is a hyperbola. I'm going to zoom this out so you can see it all at once. Again, parabola because it's equal to 0, hyperbola, hyperbola because it's greater than 1, and ellipse or circle because it's less than 0. Or sorry, because it's greater than 0. Greater than 0. that finishes notes 25.